All right, so let's take a look at this problem number 8. And I actually think there's two problem number 8, so this is the first one. I misnumbered these. Um, for your reference, the sign of x is provided here. The period is always 2 pi divided by the coefficient in front of x. The coefficient in front of x here, the coefficient of x is pi over 3. So 2 pi divided by pi over 3 is 6. And your normal period for a sine curve is 2 pi, which is about 6.28. So it's a very slight horizontal shrink here. So we're not expecting to lose any places where it crosses the center line. The amplitude is the multiplier in front of your sine or cosine. In this case, it's 3. Your center line, if the graph has been lifted up or pushed down, it's always the number that follows your function. So here it's plus 1. Now the center line is a line, so it's y equals 1. So now here, those I think are pretty straightforward. And here you have to think a little bit when you're talking about crossing at the center line. Oftentimes they ask you to how many times does it cross or where does it cross between 0 and 2 pi. And here we're excluding the endpoint of 2 pi, so maybe I should think of this as a hollow dot right there. And in other words, if they just say crosses the center line, they mean over the domain of the function or over the set of all real numbers. So, and this is often referred to as the general solution. So let's first look and see what's happening with it, where it crosses between 0 and 2 pi, and then we'll generalize it. So we know that the sign, if the input to the sign is 0, it'll be at the center line. So we take this expression, no matter if it's simple or complicated, and we set it equal to 0 and solve for x, because if you plug in this value of x, then it'll cause this expression to equal 0. So if we add that term pi over 2 to each side, you can see that the pi's cancel, multiply by 3, and we've got 3 halves. So x equals 3 halves. Now the next time that it crosses the center line is at pi. So instead of setting this equal to 0, we take this expression and set it equal to pi. We're substituting this expression for pi because we know the sign of pi, that it crosses its center line. So again, let's solve this for x by adding pi over 2 to each side. Pi plus pi over 2 is 3 pi over 2. The pi's cancel. And if you multiply both sides by 3, you get 9 over 2. Alright. So these places where it intersects the center line are equally spaced. So the distance between these two, 9 minus 3 is 6, and 6 over 2 is 3, and that's always going to be half of the period. So if we add another 6 over 2, if we add another 3 to this, 15 divided by 2, 7.5 is bigger than 6.28, so that's not on this interval. So we said it was a very slight horizontal shrink. We didn't expect to lose any of the places that cross its center line, and so here's the location, the two places that crosses its center line. To generalize this, we can pick either one of these solutions. I generally pick the smaller one, the first one, and then we add integer multiples of half of the period, of 3, since the period was 6, and we saw that the distance 9 minus 3, 6 over 2 was 3. We just add integer multiples of 3, and that'll get you to the next center line. So I hope that helps, and I'll talk to you later.